By the end of this video, you should be able to calculate the mass-to-mass conversions using factor label method. You will need a pencil, a calculator, your periodic table, and the mass-to-mass conversions video sheet. If you misplace this, you can find it on Edline. There are two main calculations you have already learned. The first is how to calculate mass to moles or back again. Whenever going between mass and moles, you should use the molar mass from the periodic table. And this mass is for that compound. So it would be for compound A. The second type of reaction you have learned how to do is going between moles of one compound, so compound A, to moles of a new compound, compound B, which is why we have two different colors. Moles to moles requires that you use the coefficients from your balanced chemical equation. Now these two steps can be put together to make longer problems. So for example, you can go from mass of one thing to moles of a new compound as long as you have a periodic table to find the first molar mass and then a balanced chemical equation for the coefficients. Likewise, you can go from moles of B to mass of B, and notice how this problem here is really the same thing as this one backwards, as long as you have the molar mass of that new compound. Since this is compound B, we can't use the molar mass for A. We would have to use the molar mass for a new compound, compound B. Let's try a practice problem. On this problem, we're going to find how many grams of hydrogen are required to make 12.5 grams of ammonia. And we have our balanced chemical equation given to us, so we can do this. First off, you want to see what you have and what you're trying to find out. So we are on this map with grams of ammonia right here. We have 12.5 grams of ammonia. We're trying to find out grams of hydrogen, so we're going to go all the way to the end and find out how many grams of hydrogen do we have. Now to do this, we're going to need to have two different molar masses. Going from mass of A to moles of A, this is the ammonia step, we need the molar mass of ammonia. Then we're going to go from moles to moles of hydrogen using the balanced chemical equation. Then from moles to mass using the molar mass of hydrogen. So this will also be for ammonia, NH3, and this will be for hydrogen. Let's write down what our molar masses are. Now a good thing for you to do would be to stop the video and find your molar mass of ammonia and your molar mass of hydrogen, and then double check your work. And what we have is the molar mass of ammonia is 17.04 grams per mole, and for hydrogen is 2.02 grams per mole. So we have everything we need at this point. We have the molar mass of ammonia, we have our balanced chemical equation, and we have the molar mass of hydrogen. Let's start with the given. Okay. We know that this unit has to come down so it can cancel out grams and NH3. On the first step, we're going from mass of NH3 to moles of NH3. So grams of NH3 to moles. The moles of NH3 goes on the top. Then we stop and we look at the molar mass to figure out what numbers to put where. The molar mass is 17.04 grams, so the 17.04 goes with the grams. 1 mole goes on the top. Next, because we're not done, we've only gotten to this point now, we've gone one step. We're going to go from moles of NH3 to moles of H2. Moles of NH3 has to drop down so it can cancel. Moles of H2 goes on the top. We're doing this step right now, but we need the balance equation to find out the numbers. So from the equation, 2 goes in front of NH3, and the 3 moles goes with the H2. Now we're not done because we want to go all the way down to this step, the mass of H2. To do that, we know our unit has to come down so we can cross it out. We're going from moles of H2 to grams of H2. So grams of H2 goes on the top. And according to this step, we're going to use the molar mass of H2 as a conversion factor. That is 2.02 grams. So 2.02 goes with the grams, and 1 mole goes on the bottom. Now, the grams of NH3 can cancel out because they're on the top and the bottom. The moles of the NH3 can cancel out, it's on the top and the bottom. Moles of H2 cancels out. Let's do the work, the math. We're going to do 12.5 times by 3 times by 2.02 divided by 17.04 divided by 2 divided by 1. And we get an answer of 2.22 grams of hydrogen. Box our answer. Notice 3 significant figures because this has 3 significant figures, that has 3, that has 4, and 3 is the least. Let's try a different problem. Same balanced chemical equation, but in this case, how many moles of nitrogen, so we're looking for how many moles of nitrogen are required to react with 9.25 grams of hydrogen. So we're going to start with our given, which is grams of hydrogen. That's a mass. We're starting here. We're looking for moles of something different, so we're going to this moles. So we're not going to have to use that section for this particular problem. We're going to have a two-step problem. We need to know the molar mass of substance A. Now, 9.25 grams of hydrogen, that's my known, that's my substance A. Going to moles of hydrogen, and then moles of my new substance, which is nitrogen, N2. I need my molar mass of substance A, which from my balanced chemical equation, since it's H2, is 2.02 grams per mole. I do not need to know my molar mass of substance B because I'm not going that far. Let's start with the given. 9.25 grams of hydrogen. As always, we've done our setup. Now this unit comes down. Grams of hydrogen. I am going from grams of hydrogen to moles of hydrogen. So moles of hydrogen goes on the top. I need my molar mass to do this. It is 2.02 grams. So the 2.02 goes with the grams per 1 mole of hydrogen. But I am not done. I've only done step 1. I have my next step to go. So I do my new multiplication and my line. The unit comes down. Moles H2. We're going from moles of hydrogen to moles of nitrogen. So moles of nitrogen goes on the top. The balance equation tells me what coefficients to put where. 3 moles hydrogen, so 3 moles hydrogen. 1 mole nitrogen, so 1 mole nitrogen. What can cancel out? My grams of hydrogen are the same on the top and the bottom, they're gone. Moles of hydrogen can also cancel out. And to do my calculation, I am going to do 9.25 times by 1 times by 1 divided by 2.02 divided by 3, which gives me an answer of 1.53 moles of nitrogen. 3 sig figs, because there's 3 here and 3 here.